Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of graph transformations. This is standard A.3E in the great state of Texas, and we are using item number 20 of the 2021 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So this graph right here shows us the linear function h. So that's going to be important for us to see that this is a line that represents h. And given that f of x equals x, but there is no f of x on this graph. So I'm going to draw that for us real quick so visually we can see that. And then h of x equals a f of x. So something is happening there to where our f of x is being modified by this a. We need to figure out what that value is. Well, might seem kind of confusing right now, but let's graph our x and our, really it's our y, but it's going to be our f of x. Let's do this for function f real quick. Right, so if f of x equals x, then that's 0, 0. It's going to be easy. It's going to be 1, 1, 2, 2, 3, 3, right? Your x and your y are equal. So it also goes to the origin, just like h does. I'm just going to draw some dots, but you notice it's not quite parallel. Obviously, they intersect, right? But if I were to draw these dots and then connect them, and if you were doing this on paper, you'd want to probably do this with a straight edge. You notice it's not going to be exactly the same. The slope changes a little bit. So I'm going to try to draw it right here. Get through all these points, extend this down right here. So let me rewrite h up here. So this is going to be my f. Okay, so what happened from f to h? Well, the slope changed a little bit. It went down just a little bit. So two things when we're dealing with linear functions here, right? Two things could change. It could be the slope. It also could be the y-intercept. Now, both of these are what we call direct variation, right? It's y equals kx. Simply because they're proportional, they both go through the origin. So we don't have to worry about the y-intercept. They're both 0. It goes to the origin. So what changed? It's the slope. The slope changed. And take a look at this equation right here. h of x equals a f of x. Okay? So if we wanted to substitute, right, f of x equals x, I'm going to rewrite this, but I'm just going to substitute my x in for my f of x. It might make a little bit more sense. h of x equals a, and then instead of that f of x, I'm just going to write x because we know that f of x equals x right here. Well, this looks an awful lot like this, right? So we've got this is our y, that is our dependent variable. Here's our x, this is our independent variable, and look, we just need the slope. So what is the slope of h? All of this is asking, what's the slope of h? Well, you know what? I've got 2 points right here. I can just use my equation for slope, right? So slope is change in y over the change in x. I could tell you that it got shifted down a little bit. It's a little bit shallower, so it's going to be less than 1. When it's greater than 1, it becomes steeper. So let's label this x2, y2, and x1 and y1. All right, so that's going to be 8 minus negative 4. That's going to end up being a positive. Then it's going to be 10 minus negative 5, also going to be a positive. So it's going to be 12 over 15. So if I reduce that, right, 4 or 3 is going to go into that 12 4 times, 3 is going to go into 15 5 times, 4/5. Now, it needs to be a decimal here so I can bubble it in, but I would just bubble in 0.8 or 8/10. That's equal to that, and that's your answer.